welcome to my channel. So let's have a look at problem 54, spiral matrix together. So actually in the previous video for Leetcode Problem 23, 26, so we explained the general method of rotation matrix for doing spiral traversal of matrices. In that video, actually, we forgot to ask a question. So in this video, we are going to ask that question and then share the intuitive solution for this specific problem again, just to demonstrate the use of the rotation matrix method. Let's first read through the statement of the problem, then analyze the method. So here, given an m by n matrix, so we are required to return all the elements of the matrix in a spiral order. So in this problem, so we are going to use in a clockwise spiral order. For example, in example 1, we first traverse horizontally along the first row, and then we traverse downwards up to this 9, and then we traverse to the left up to 7, then up to 4, and then 4 to 5. So that's one example. Similarly for example 2, we do not explain anymore for this example. So the constraint about this problem, so the number of rows and columns are bounded above by 10, and the elements in the matrix is bounded by 100 by absolute value. So actually this number of rows or columns can be enlarged, or this range condition can be relaxed in our solution. So the solution still works. So here, let me explain the method. So the method we're going to use is the rotation matrix method. So here, the problem essentially is a spiral traversal of this matrix, right? So the key question in this spiral matrix is to decide where to change traversal direction, and how to update the direction. So for the first question, so decide where to change the traversal direction, that's not hard. The reason is that once we meet the boundary of the matrix, or we meet the boundary that the previous one already traversed, then we change direction. So each time we change direction by rotating the direction by 90 degrees in a clockwise fashion. And the thing is how to update direction. So this is exactly the role played by the rotation matrix. So in here, I want to write down the rotation matrix directly here for this problem. So here the rotation matrix is 0, 1, and negative 1, 0, right? So in other words, so if we originally we have a direction, that is our direction is let's see, dr, dc. Then if we want to update that direction, so we can do matrix multiplication. Let's call this matrix R, and this is the vector direction, right? So then the new direction will be R matrix multiplication, this direction. So if originally is R, dr, and dc, and then it's going to be dc negative dr. So that's all about this solution. So if you want to have a better understanding on how to get the rotation matrix and how to reset the direction, so you are welcome to look at this video. So it has the full details, and this is a continuation of that video. So we're not going to explain all the details here. Actually, the question we want to ask, or the challenge we want to raise is how can we can we do this problem using counterclockwise spiral traversal? Clockwise spiral traversal. So that's the question that we forgot to ask when we do this video. But it's this question is good in the sense that it helps us to really understand the rotation matrix method and understand this method in general. So with that said, let's look at the code. So here, this is a solution that we set down. So with some optimization, that we get a valid solution. This is not the method or format we're going to share here. So this method actually uses less space, but setting the index boundaries can be error prone. So in a time pressing situation, we might not able to write it correctly. So with that said, I'm going to delete this part. So as if you want to try this solution, you can stop the video here and tap out this solution. So what I want to do here is going to using a rotation matrix solution. This is to me very intuitive. First, I'm going to track the information about the rows and columns of the matrix. So this is a routine, and then I'm going to set a result, an empty list, which to hold the elements we traversed, and also we want to also set a variable called count, which if we traversed all the elements, m by n elements, we're going to break. Right, so we have RC, this is the initial position we are going to traverse, and also the direction for the traversal is DRDC. Originally it's horizontal, right? So we didn't change the row, but we increment the column by 1 each time. So this is the direction. So now we want to use a visited site just to record the elements we have already visited. So this is not absolutely necessary, but to fix the idea and to explain the logic clearly, we used here. So then basically it's a while loop. So we do the traversal while the count is less than m times n. What we want to do is that we append the result with the current element we are looking at or traversing. That is matrix RC. So once we finish traversing this position, we're going to update this set visited and add this RC. Then we're going to count by incrementing this by 1, right? Increment the count variable by 1. This is natural. And then we're going to check if we need to do a position change, direction change. So we're going to check if r plus dr is less than 0, or r plus dr is greater than m, or c plus dc is less than 0, or c plus dc is greater or equal than n. So here is also greater or equal, I would say. Or dr r plus dr c plus dc. So this is going to be the position we're going to update for r and c. So if it's in visited, so if this guy is in visited, so we're going to change direction. So the direction should change like this. So dr dc to be dc negative dr, dc negative dr. Once we've done this direction change, we're ready to update the position to traverse. So r plus dr, c plus dc. So with that said, we're ready to return the result. So let's first do a special case check. It passes the first example. Now let's look at example 2. It also passes the example 2 here. So now let's check the generic case. Oh yeah, it passes the generic case. So here let me emphasize after we see this full solution here. So this full solution actually is sort of identical to the solution to problem 26 in essence. But here we want to emphasize the question again. So can we do this problem or practice this problem? So if the problem requires to do the traversal in a counterclockwise fashion. So that's about it for this problem, I would say. Thank you very much.